Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you transaction management, in which I'll talk about the definition of a transaction, the asset properties of the transactions, and different states that a transaction can be in. So let's begin. First, let's define a transaction. So a transaction is a collection of operations that form a single logical unit of work. And here you can see on your screen an example of a transaction. So what you can see is you can see some read statements and some write statements. And basically what this transaction does is transfer some amount from one data item to another. So as you can see, there is data item A, and from data item A, 50 is deducted, and then the same 50 is added into data item B. So this is how a transaction works. And if you're having trouble understanding what this is, then I'll give you an example of SQL. So consider this, that you have created in SQL a table that contains details of all the bank accounts of different types of people. And so there's an account A and there's an account B. And in account A, what you want to do is remove $50 and then transfer the same $50 into account B. So this is the same type of transaction. So whenever I say that there is A equal to A minus 50, that means you are actually writing an update statement where you're saying update this table containing all these details of different accounts and then deduct 50 from the balance. And then you're writing another update query that says add this same amount, which is 50, into somebody else's account, which is B. So consider all these data items as, you can consider them as different tables or different queries in SQL. That would help you to better understand this unit, because this entire transaction processing topic contains transactions written in this manner only and not in the form of SQL statement. Now, in this example, I would like you to notice some of the things that are given. And first, we are going to look closely at the read function. So the read function, what it does is transfers data item A from the database to a variable, which is also named A, in a buffer in main memory belonging to the transaction that executed the read operation. Whenever you want to work with data in SQL or anywhere else, you require the data to be present in your main memory. And to do this, you have to transfer the data from the secondary memory to main memory. And that is what the read function here does. It transfers data, which is in this case, the value of data item A, into another variable. And that variable is also called A, but this time this variable is not in the secondary memory, but in the main memory. And so this variable then comes to the main memory, and you can apply whatever functions you would like to apply to this variable. You can update it, you can delete it, you can insert more things into it. And that is how the read function works in SQL transactions. Now let's take a look at the write function. So the write function transfers the value of the variable A in the main memory buffer of the transaction that is executed to the data item A in the database. And when we say database, that means we're talking about the secondary memory where data is permanently stored. So you can see here that once I have done all the calculations, let me show that to you once again. So this is the transaction. And once I've done everything, once I have added, subtracted, whatever I wanted to do, you can see that I'm writing write A and write B. This makes all my changes permanent. So that is why I'm doing write A and write B. So this essentially is actually writing everything from main memory into your secondary memory. And that's why we do this. That's why we perform the transaction in this manner. So there's a read operation that fetches things from the secondary memory to the main memory. And then there's a write operation that writes everything into the database, because we all know that data in main memory is always volatile and it will disappear the minute you close your system. So whatever changes are made, they have to be permanent, and that's why we do the write A operation. Now, let us see the different types of asset properties in transactions. So all transactions have to follow these properties. These properties are there so that the transactions do not affect the database in an adverse manner. So if these properties are not satisfied, then your database will suffer a loss of data, or it could be some discrepancy in the data. And to avoid all these things, we need to maintain all these properties for all types of transactions. And these properties are atomicity, consistency, durability, and isolation, as you can see. And we're going to take a look at them one by one. So let's begin with atomicity. Atomicity is where either all operations of the transaction are reflected properly in the database or none is. So this means either your transaction is fully executed or it is not executed at all. It should not be somewhere in between, because when it's in between, it will cause some problems. And I'll show you that with an example. So consider the same example that we saw earlier. This is the transaction T1, which transfers 50 from account A to account B, or data item A to data item B. And now in this, consider that in this area that is visible right here, in this particular area, there is some failure happening. And that's a topic for another video, what types of failures can occur. But this failure could be anything. It could be software, hardware, any type of failure. And when this failure is happening, your transaction is stopping right in this position. So it's either finishing these first 3 tasks and then it is stopping, or it is finishing the first 4 tasks and then it is stopping, or the first 5 tasks and stopping. Now, because the first 3 tasks are happening, let's assume that the values of A and B are 1000 and 2000 respectively. If the first 3 tasks finish successfully, that means the value of A is already subtracted and it is already stored into the system. Then this is what your new value will look like. It means A is now 950 and B remains 2000 if there is any error in this region that I talked about. Because before the transaction got a chance to make the value of B permanent, it failed. And due to that, the amount got deducted from A but did not get added into B. And imagine that if this were an actual banking system, then you'd suffer great losses if this type of thing happened. And that is why we need to maintain the property of atomicity, which says that all transactions must either be completed fully or should not be completed at all in order to prevent this type of a case from happening. Now let's see the next property. The next property we're going to see is consistency. So consistency means the correctness of data in the database, which means your data should be correct at all times, no matter how many changes are made to it. And this consistency is affected by concurrency and non-atomicity. And you are by now familiar with atomicity, but you do not know what is concurrency. So concurrency is when there are multiple transactions happening at the same time. And this is quite normal in any type of a system. Even if it's a banking system, there are so many transactions happening in the same minute. And if you ask every person to wait for somebody else to finish a transaction, the system would be quite slow. So concurrency is a necessity, but concurrency could cause incorrectness in the data. Of course, this can be handled, and we are going to see in some of the later videos how you can handle the issues related with concurrency. So consistency can get affected because of this concurrency and because the uh, and if the atomicity property is not followed. Now this brings us back to our previous example where we saw this transaction, and I told you that if atomicity is not followed, then it can happen that the original values of A and B are 1000 and 2000, but after the transaction executes, and because it fails, it might become 950 for A and 2000 for B, which is of course incorrect because the total of A and B does not match in both the cases. In the first case, it is 3000, and in the second case, it is 2950, which is 50 less, which means somebody lost some money. So this is the case which is of incorrect data in the database. And to prevent this, of course, you need to follow atomicity and you need to take care of concurrent transactions, which, as I mentioned, we are going to see in one of the later videos. Now let's take a look at the next property of transactions, which is called isolation. So isolation is where each transaction in the system is unaware of another transaction occurring concurrently. Now, obviously, transactions are not human beings, and so they do not have the quality of either being aware or not aware. But what I mean is, when you are doing a transaction, it could be in your banking system, or it could be any type of transaction, maybe booking of tickets. So in such cases, you should not be aware of somebody else also who is booking the ticket at the same time or performing a transaction at the same time. If you know that somebody is doing it along with you, then that's not a very good system and it can cause problems. So later on, I'm going to tell you the different types of levels of isolation once we have covered a topic called serializability. But for now, the definition is enough. Now let's take a look at the fourth property, which is called durability. And as the name suggests, this is where we ensure that all the data that the transaction has manipulated remains that way in the system. So after a transaction is completed successfully, all the changes that were made in the database must persist. Persist means must remain in the system even if there are any system failures. So even if there are failures, your data which was updated or inserted or deleted must not be lost. It should still be present in your system intact. And that is the property of durability. Now, since we've covered all four properties, I would like to talk about the different states of a transaction. So a transaction has its own life cycle, and we're going to see what that life cycle looks like. So the different states of a transaction are like this. First, we have the active state. Then from the active state, the transaction can go to a partially committed state, or it can go to a failed state. From a partially committed state, a transaction can also go to a failed state. From a partially committed state, a transaction can also go to a committed state. And if a transaction has failed, then it has no other choice but to go to the aborted state. So these are the 5 states of a transaction, and a transaction can be in any one of these 5 states at any given time. So let's take a look at all these 5 states one by one. The first is the active state. The active state is obviously the initial state of the transaction. And as long as the transaction is working or doing any type of execution, it will remain in the active state. Once it is in active state, it can go to the partially committed state. So the partially committed state is where the final statement of the transaction has been executed, but it's just waiting for the system to give a green signal of having been committed to the memory fully. Because it's not just that the transaction is successful, but sometimes the transaction is dependent on other events and other transactions to be successful in order to be successfully written into the secondary memory. So till that happens, and as long as the transaction has completed all its work, and till it's as long as it's waiting to be committed, it is in a partially committed state. And then, like I mentioned, a transaction from active state can go to a failed state, and also a transaction from a partially committed state could go to a failed state. So what is the failed state? The failed state is when a transaction has failed after a discovery that it cannot proceed with its normal execution because of some type of error. It could be an error within the transaction itself, or it could be an error because of the system. And due to all these reasons, the transaction could be in a failed state. Now, obviously, once it's in the failed state, the only option for the transaction is to go to the aborted state, which we're going to see later on. First, let's take a look at the committed state. So the committed state is when the transaction has successfully completed, and not just completed, but all the changes that the transaction has made in the database is also successfully written into the database. This is what the committed state means. And finally, the aborted state. The aborted state is when a transaction has failed and then you have no choice but to roll it back. Now, what is a rollback? Rollback is where you take your transaction back to an initial or beginning state, and then you try to execute it again, or you just leave it as it is. So if suppose the transaction fails after performing some operations, then you would roll it back and bring it to the initial state, which means whatever changes were done by that transaction would be removed from the database completely. That is what aborted state means. Now, once the transaction is aborted, there can be two things that you can do. The first is you can restart the transaction, and the second is you can kill the transaction. So restarting the transaction means you just start the transaction from the beginning again. But this can only be done if the transaction failed due to a system error. For example, you did not have enough memory in your system. And so maybe now there is free memory available, and that's why you're able to restart the transaction. Or it could be that there was a power failure, and now the power is back, and so you can restart your transaction and do it again. But sometimes there could be a problem with the transaction itself, and this could be a logical error made by the person who wrote the transaction. And we do that many times in our programs when we make errors. So due to these errors, the transaction cannot run, and there's no point in restarting it because the transaction itself is incorrect. So in such cases, you would be killing the transaction. That means not restarting it. You'd write a new transaction and then run that transaction, or maybe correct the current transaction. So that is what the aborted state means. At any given point, a transaction that is either committed or aborted is known as a terminated transaction. So a terminated transaction is either in the committed state or in the aborted state. And that's it for this video. I'll see you in the next one. Thank you for watching.